All right, let's talk about repeated zeros. These are zeros that occur 2 or more times. You're very familiar with the perfect square idea. X squared minus 4x plus 4, n equals 2, so there must be 2 zeros. So 2 there is a zero twice. Repeated zeros impact the x-intercepts of the graph. So let's check it out. We have a repeated zero. If k is odd, then the graph will cross the x-axis at x equal to a. All right, let's take a look with our calculator here. Let's find the zeros of x to the fourth minus 5x squared cubed, plus 6x squared plus 4x minus 8 with regard to x. Oh, only 2 zeros. Remember, we should have 4 of them. So what we do is we go back, and instead of asking for zeros, we're going to ask it to factor. Notice that the 0, 2 is used 3 times. Now that means, if you remember from the beginning of this, that if we were to draw a graph, it would go through the x-axis and sort of do a jog. So let's get it set up here. We want to store this in y1 of x. It's always good to store, so that when we go to y equals screen, we can there's our function and we didn't have to type it in again. Now we're going to zoom, and we'll try for zoom standard. Takes a couple minutes for it to collect all of its points. And do you notice how it jogged across the x-axis there at 2? But at -1, it went straight over the x-axis. A jog means we have an odd multiplicity. Now, if k is even, let's talk about that next, then the graph is going to touch the x-axis, or you might consider it to be tangent to the x-axis. All right, let's put a function in here. Let's find the zeros of, a fifth order. Very good. Plus 7x to the fourth plus 16x cubed plus 8x squared minus 16x. That's good. We got a minus sign there. Minus 16. And we're looking for the zeros. Now remember, how many should we have? We should have 5. And there's only 2. Now, at least one of those has to be used a multiple number of times. So you remember what we do? We go back here and we change zeros to factor. Notice -2 there is used 4 times. Now, how is that going to go across the x-axis? Well, let's check out a graph again. So we need to store this. We need to store it back in y1 of x because we're done with that other one. We don't have to keep going in there and finding a new y. Go to the y equals graph. Y equals screen. Yes, there's our function. Okay, now, in this case, zooming standard, we wouldn't see much of the graph. So notice how you can change your window. We need x min to be -5, x max to be 5, y min is -25, y max 10. We'll scale it at 2, and let's watch a graph appear. Now remember, something interesting should happen at -2. Aha! Do you see the tangent happening there? And then at 1, it goes straight through, because x equal to -2 had a multiplicity of 4. Now, the next video contains examples of the various ideas that we have discussed in this section. We're going to put everything together.